Hello, we are here for one more lesson of this T-Flex CAM training course. And the topic for today will be the first toolpath of 5-axis milling, and in particular it's called 5D contour milling. So inside the CNC menu we have, as you already seen, a couple of functions, and now we are going to see this group here called 5D milling. This 5D milling has two options. The first one, 5D contour milling, and another one called 5D surface milling. Today's lesson will be about this first option. Anyway, the first important thing to explain you is that in future versions, these functions of this group, the 5D milling, will be discontinued. So we will see this briefly, because these are functions that will not continue, and even that at this moment they work, but the strategy of milling in 5-axis will change. So to show you now what we can do with this function, I've uploaded this model here, very simple part. I've created one contour on the side of this part, on this surface here, and we can go to 5D milling, and now I will choose 5D contour milling. I will choose my contour, which is this one here. I will load my file. I have only one tool, and you can see that is a 4 mm diameter, spherical. So it is okay. These parameters, feed rates, rapids, and work feed rates, allowances, you know them already, so it's not big deal. Rotation, spindles, and directions, and pass type by contour or in the opposite direction. And if I don't say anything else, just say calculate, I will have a toolpath that basically will do something like this. So simply go on the surface and following the contour. So, and the axis is fixed. But I can change this a little, even that I don't have many options, but I can edit this. And I can work with the angles. So the tilt angle and the yaw angle. The first one, the tilt angle, is it is explained because it's the angle along the direction of the motion, and this second one, the yaw angle, is the perpendicular to the direction of the motion. So as an example, if I say, for example, here 30 degrees, the angle will be fixed. So confirm and do the simulation. And as you can see, looking for the z-axis, it is parallel to it is parallel to the plane xz, but with the angle of 30. So as you can see, okay, this is the first parameter. If at the same time you deal with the second parameter, the yaw, I will say 45, or even a little more, 60, then we will have something like this. So it's no longer on the plane xz, so it has two angles. So this is a question of giving the right direction to define the proper angle. and you'll get the results that you want. Because working on top of these curves, you must be careful because the angles are fixed, and for some geometries you may have problems with collision. So it's just a matter of understanding this notion of the angles. So I will not lose too much time on this, for the reason that I mentioned in the beginning of this lesson, that these two functions will end. So for the moment, if you need to use them, they are usable with these very easy topics. But don't lose too much time with them, because they will stop. So any questions or problems that you may have for the moment with these functions, you can contact us for any support you may need.